Let's look at some examples of mean, variance, and standard deviation involving binomial distributions. So let's take a look at this question from your homework. So 34% likely U.S. voters think the federal government should get more involved in fighting local crime. You randomly select 6 likely U.S. voters and ask them whether they think the federal government should get more involved in fighting local crime. The random variable represents the number of likely U.S. voters who think the federal government should get more involved in fighting local crime. So find the mean of the binomial distribution. So the way we can find the mean is basically all you gotta do is multiply the number of trials times the probability of success in each trial. So for our problem, it's going to be the number of trials was, you selected 6. And then if we multiply that by the probability, which was 34% chance of being likely, that'll give us what we call our mean. So 6 times this 0.34, so 2.04. So 2.4 would be our mean. So what they're saying is if you pick 6 voters, about 2.04 voters would say, yeah, we would like to see the federal government involved in local crime fighting. So then to find the variance of this, we have the variance is sigma squared. And what you do is you multiply the number of trials times the probability of success of each trial times the probability of each failure of each trial. So sigma squared is going to be then this number of trials we said was 6. 0.34 was the successes of the trial. And if we go 100 minus 34, if you will, let's see here. So yeah, 0.66 would be that. That would be the probability of a failure. So like I said, most people do not want to see the federal government involved in local crime fighting. So based on this material here. So if we do the math there, 6 times 0.34 times 0.66, that'll give us our variance. If we round to the nearest 10th, that would be like 1.3. Now, the next question is standard deviation. Standard deviation is sigma, so that's going to be the square root. And I'm just going to take the square root of the answer that we have up here. So second square root of this 1.3464. So answer is right above the negative symbol. Hit second negative and hit that. That'll give us this 1.2 as our standard deviation. So if I actually took the square root of 1.3, I don't know if that changed a whole lot. Second square root of 1.3, that gives us 1.1. So I don't know which one. They may both work. Sometimes there's a little bit of tolerance built into the system, but most of the time I don't do any rounding. I feel safer with that, but you can kind of play with that. So, so I actually took the square root of 1.3464 is what I took the square root of. So if I want to interpret my results, one way we can interpret them is in most samples of 6 U.S. voters, the number of voters who think the federal government should get more involved in local government should differ from the mean by no more than what? So if you're differing from the mean, that's what standard deviation is. Standard deviation is how far you vary from the mean or differ from the mean. So that would be what would go here would be the 1.2. So basically then you're talking about, you know, a range. Then if you go 2.04 minus 1.2, that gives you 0.84. Then if you go 2.04 plus 1.2, 3.24. So that would be the range of the people who would be okay with federal government being involved in local crimes. So like 0.84 of a person to 3.24 of a person. It's kind of what we're getting into there with that math. So that's how you can kind of determine mean, variance, and standard deviation involving a binomial distribution.